So yesterday we talked about how the derivative of the definite angle from c to x of f of t dt is just going to be f of x. And if this is c to u, something in terms of x, an expression in terms of x, we're substituting u in for t, but then we have to multiply by the derivative of u, just basically using the chain rule. What we're looking at today is more concentrating on the first part here and tying it in with some old stuff that we've done. So let's take a look at the first one here. Something you'll see on AP tests, like free response, multiple choice, is functions that are integrals. So we have capital F of x equals the definite integral from 0 to x of f of t dt, where the graph of f is shown to the right. So here's our graph of just regular little f of t. And then capital F of x is the definite integral from 0 to whatever we put in for x. Remember, the definite integral represents the area under the curve. So we're going to fill out this table basically just finding the area under the curve for each different scenario. So the first one is f of negative 2. Well, that means we're going to do the definite integral from 0 to negative 2 of f of t dt. Which means we're finding the area under the curve from 0 to negative 2, but that's kind of backwards from the way we should be doing it, right? The smaller number should be on the bottom. So how can we fix that? We talked about this yesterday. Switch A and B, but what else do we have to take into account? Negative on front, right, to keep things the same, because by switching A and B it makes it the opposite, and then by putting the negative it keeps it the same as the original. So we want to find the area under the curve from negative 2 to 0 of f of t dt, and then we're multiplying that basically by negative 1. So the area from negative 2 to 0 is going to be this little region right here. This is the height of our trapezoid, right? Distance between the two bases, that's 2, because we're going from negative 2 to 0, it makes it positive. This is a base of our trapezoid here, and that's actually negative 6, right? That's why our area ends up being negative. It's under the x-axis. And this one is negative 2. So if we're looking at the area of this trapezoid, we have 1/2 times negative 6 plus negative 2 times 2. So 1/2 times negative 8 times 2, we're going to get negative 8. But remember, we have this negative out in front of the integral, so really that's going to make it a positive 8. So we have the negative on the outside, negative 8 for our area. We get an area of 8. So f of negative 2 comes out to be positive 8. Not always that complicated with the negatives and everything. But let's take a look at negative 1. Kind of a similar situation there. If we do f of negative 1, we get the definite integral from 0 to negative 1 of f of t dt. So we want to switch that around so that we're going from negative 1 to 0. So now we're just looking at this little trapezoid, right? From negative 1 to 0, we have the area for that one, 1/2 times base 1. This base right here is going to be negative 4. This base is negative 2. And then the height, the distance between those bases, is just 1. So we get negative 6 times 1/2, negative 3 times 1. So we have negative 3, but there's that negative out in front. So that's going to give us a positive 3. How about 0? If we put 0 in for x, that's a nice easy one. If we have the definite integral from 0 to 0, our answer is 0. I want you guys to go ahead and finish the rest of the table. These are going to be a little bit easier. There's no like negatives and flipping or anything like that. So why don't you go ahead and try the rest of this, and we'll come back and look at it together. All right, so let's take a look. At 1, we're taking the definite integral from 0 to 1. We're just finding the area of this little purple triangle right here. So area of that is going to be 1/2 times 1 is our base. Height is negative 2. So we get an area of negative 1. Then the area from 0 to 2, so for f of 2, we're finding the area of both of these triangles added up. Well, I already know this one's -1, so area of this one is going to be +1, right? It's the same triangle, only it's above the x-axis. So when these two get added up, we get an area of 0. Then 3, we're doing the definite integral from 0 to 3. Well, we already know definite integral from 0 to 2 is 0. I'm just going to find this little blue part. Now, let's say I didn't have to do the other parts already. If I was finding the area from 0 to 3, I'd have to find the area of this triangle, the area of this triangle, add them up. But I already know these cancel out and add up to 0. So if I find the area of this trapezoid, that's 3 plus 0, we know the area from 0 to 3 is going to give us 3. Kind of the same idea with this last one. We know the area from 0 to 3 is 3. We figured all that out. I'm just finding the area of this little trapezoid and adding it on to 3. Gives us an area of 8. Again, another approach, find the area of this triangle is -1. Area of this triangle would be 9. So 9 plus -1 gives us 8. Now, other two parts are a little bit simpler, but I have to remember some stuff from before. It kind of ties in with our class starter from today. On what interval is f increasing? So, how do we know if something's increasing? Its derivative has to be positive, right? So f is increasing when derivative of that is positive. So what's the derivative of f? Right, from what we talked about yesterday? Derivative of this definite integral from a constant to x is just going to be f of x. Right? So the derivative of this is f of x. So this graph right here is really the derivative of capital F of x. So when is this graph positive? From 1, not the slope of this graph, but this graph itself, right? The y value of this graph represents the derivative. So the y value is positive from 0 on to infinity, right? Sorry, 1 to infinity, thank you. So from 1 to infinity. It doesn't say to justify, but we're going to do it anyway. F is increasing from 1 to infinity because the derivative of f, which is equal to f of x, is positive. All right, and I should have put justifying here that generally you're going to have to do that on free response. Decreasing would be when derivative is negative, and that would be, in this case, just when it's less than 1, right? So f is increasing. Sorry, decreasing. I was just copying. F is decreasing when around the interval from negative infinity to 1, because the derivative of f of x, which is equal to f of x, is negative.